So for the parallelograms, we're going to wrap everything up with the parallelograms in terms of quadrilaterals here. A lot of this, what we do is try to see if something is a quadrilateral or what kind of quadrilateral it is. It's parallelogram, rectangle, rhombus. If it's both of those, then it's also a square. We do that by taking a look at the properties. Now, whether we're finding the variable or not, it's the same thing. We look back at those properties you found from the activities. So here, in A, what do we have in front of us? Well, we definitely have a quadrilateral. And what part of the quadrilateral do we know? Well, we know something about the diagonals. What about the diagonals? Well, they bisect each other. If that happens, we know it's a parallelogram. Okay. Now, how about for a rectangle? Are the diagonals congruent? Well, 16 and 12, nope. So it's not a rectangle. Can't be a square then. How about for a rhombus? We know nothing else. If that's the only information, we don't know anything about sides or angles of the diagonal, if the diagonals bisect the angles or not. So we're done. So the best we can say is that it's a parallelogram because diagonals bisect each other. So in B, okay, all four sides are congruent. So we know it's a rhombus. Yes, that's also a parallelogram, but we could jump most specific. That's a rhombus. Do we know if this is also a rectangle? Those sure look like they're right angles, but we don't know that. We can't say that they are because maybe they're 88 degrees and 92 degrees. We wouldn't be able to tell. So the best we could say is that it's a rhombus because all four sides are congruent. Okay, how about C here? Let's see, we do have a pair of sides congruent. We do have a pair of sides parallel. Oh wait, we had that one property in parallelograms. But the thing is, it has to be the same side. Since these are not the same side, same pair of sides, we have these pair of sides are congruent, the other pair of opposite sides are parallel. Can't say anything about it. So all we could say is that this is a quadrilateral. Nothing special at this time. Okay? And what we would say is it does not fit a property. Okay? Now, other kinds of things we do is stuff like this. So, here we've got the coordinates of a quadrilateral. Now, if you want to graph that, you can. I'm just going to do a quick sketch. So, -2, 3, here is A. -5, 7 would be about here. 3, 6 is about here for C. And D is somewhere about here. Now, we can't say anything just by looking at the figure. It looks like we can. It looks like it might be, but we can't say that. So we have to actually go ahead and show it. How do we show it? We got two ways. We could use slopes, and that's the way I would suggest because it's quicker. Now, a couple things. Remember, parallel. For two things to be parallel, we have equal slopes. perpendicular, I use the symbol. We have slopes that are opposite reciprocals of each other. So I'm just going to go ahead and what are the different slopes? Now if you remember, think back what slope was, the change in y over the change in x. So I'm going to say, okay, what is the slope of segment AB? Well, change in y, 7. I don't know why that's there. Undo that. Undo that. So 7 minus 3 over negative 5 minus negative 2. And we get 4 over negative 3. What's the slope of segment BC? C. I don't know why I can't see what I got here. So that would be 6 minus 7 over 3 minus, don't want magic pen, negative 5, 1 over, negative 1 over 8. Now, I could just keep going down the list there, but I'm going to put the next one over here of, sorry, C, the slope of CD, because notice AB over here and CD over here are opposites. So I'm going to line up the opposites next to each other. So that would be 6, I did it again, 6 minus 2 over 3 minus 6, 4 over negative 3, and then close up that with segment DA. What's the slope of DA? So that's 2 minus 3 over 6 minus a negative 2, negative 1/8. So now this is where I check first. Okay, opposite sides paired up. Are they parallel? Do they have the same slope? Negative 4/3, negative 4/3. Negative 1/8, negative 1/8. So we do have a parallelogram. That's good. Do we have a rectangle? Well, our consecutive sides perpendicular. So it's negative 4/3 and negative 1/8 opposite reciprocals. No, not even close. As soon as we get one that isn't, we're done. Not a rectangle. Now to check for a rhombus, what we have to do is look at for the diagonals. What are the, because the property of the rhombus we're going to use for slopes is that the diagonals, so BD and AC, are perpendicular. Are they? Well, what's the slope of AC? So AC would be the y values 6 minus 3, x values 3 minus negative 2, 3/5. Let's do the same thing for BD. Y values 7 minus 2, and then negative 5 minus 6, so that's 5 over negative 11. No, they're not opposite reciprocals. They're close. I mean, one's positive, one's negative. That makes them opposite signs. Positive slope, negative slope, opposite signs, but they're not reciprocals. Reciprocal would be 3/5 and 5/3. No good. So the best we could say it's a parallelogram. Now, you could, if you really, really wanted to, I shouldn't put it that way, but if you could, if you wanted to, you could use the quadratic, not the quadratic formula, but the distance formula to find the length. And then that would be the change in the x. I'm just going to use a symbol we've seen before, delta meaning change, squared. The change in the y's, squared. So you would do all four sides. Opposite sides would have to be congruent to be a parallelogram. Rectangles, you have to check the diagonals. Are the diagonals congruent? For a rhombus, all four of the sides would be the same length. Okay? That's why it slopes quicker, I think. Less chance for error, so that's what you're going to go, that's my suggestion. Okay? So that's what you practice as a few things of.